Hello learners, I Dr. Amit Tapkir from Progressive Education Society's Modern College of Pharmacy, Yamuna Nagar Nigdi, Pune. Welcome you all in today's discussion on quinolones. After watching this video, the learner will able to describe, predict, outline and design chemical basis of pharmacology and therapeutics. Explain, determine, justify and formulate some route for the chemical synthesis of some drugs. And the learner will be able to describe, summarize, apply, illustrate the importance of resistance to drug and its significance, use and abuse of drugs. Content of today's discussion, the part 1, introduction, mechanism of action, is we finished in a first lecture. In today's lecture, that is in a part 2, we are going to discuss chemistry and activity. In next part, that is a part 3, that is next lecture, we are going to discuss structure activity relationship, toxicity, pharmacokinetics and drug interaction of quinolones. First generation quinolones, from norfloxacin to other first generation fluoroquinolones, that is pfloxacin. In first section, we learned that which are the things we have to modify so the drug become more potent, more active, which increase the spectrum of activity. That is, the next generation drugs should be active against gram positive as well as gram negative and anaerobes. Also we are learn about what are the things, what are the modification we have to do in a structure so the T half will get increased. We are continuing this section with some other examples. In first, that is norfloxacin to other first generation fluoroquinolones, that is a pfloxacin. In norfloxacin, the piperazine ring, which is present at 7th carbon atom, on that piperazine ring, the methyl group is added, which is shown by the arrow. This methyl group was responsible for still increase in half-life of a drug. So, this modification from norfloxacin to pfloxacin by addition of methyl group, we increase the half-life of a drug. The another example is from norfloxacin to other first generation fluoroquinolones, that is ofloxacin. So, norfloxacin to ofloxacin. In ofloxacin, the N1 nitrogen and C8 carbon is bridged by a closed ring, that is the morpholine ring. Then the methyl substitution on piperazine ring will remain same as a pfloxacin, and you will get a next derivative is known as a ofloxacin. And the change, that is a formation of a morpholine ring between N1 nitrogen and C8 carbon, which is shown on slide by the red arrow. Next example is from norfloxacin into the other first generation fluoroquinolones is ciprofloxacin. You can easily find the change in ciprofloxacin that indicate by the orange headed arrow, that is a cyclopropyl group is added at N1 nitrogen. The ethyl group is replaced with the cyclopropyl group, and this cyclopropyl group is increasing the potency of compound. So in this way we change the structure will get the first derivative, that is p-floxacin, second derivative ofloxacin, and the third derivative is a ciprofloxacin. The discovery of nalidixic acid, oxalinic acid, synoxacin, pipermidic acid was done in 1960 to 1970. In this decade, these quinolones was discovered. From 1970 to 1980, the norfloxacin, p-floxacin, ofloxacin, ciprofloxacin, these first generation quinolones was developed, which have a improved anti-gram negative activity and T-half also best. Look at the slide in which the ciprofloxacin, which shows the very good activity indicated by the 3+ sign and having a T-half 3 to 4 hours. So this is the example how the structure will get changed and how the activity of that drug is improved. This slide gives you a feel about the first generation fluoroquinolones. All first generation fluoroquinolones structure and their modifications are shown in this slide. First is a norfloxacin, where the piperazine ring is attached. Second is a ciprofloxacin, in which cyclopropyl group is attached at N1 position. P-floxacin, methyl substitution at a piperazine ring. O-floxacin, morpholine ring, and the rest of the structure is again the same as p-floxacin. So this is the fourth generation fluoroquinolones. Then we will see the ciprofloxacin. Ciprofloxacin is administered by IV route. The spectrum of activity is ciprofloxacin is active against gram aerobic rods, Legionella pneumophila, and other atypicals. Poorly active against Streptococcus pneumoniae. Next example is levofloxacin from ofloxacin. Ofloxacin is in a racemic mixture. If you separate the S isomer of ofloxacin, then you will get levofloxacin as a drug. So levofloxacin is the pure S isomer of ofloxacin. The present first generation of fluoroquinolones. Levofloxacin have a T-half 6R and it is more active, that is twice active as ofloxacin per gram. How to improve the other therapeutic usefulness of the fourth generation fluoroquinolones? In that, first, maintain the gram negative activity, improve the gram positive activity that we can achieve in a second generation fluoroquinolones, and third one is acquired activity against anaerobes. This is achieved in a third generation fluoroquinolones. Now we going to move to the second generation fluoroquinolones. The second generation fluoroquinolones was developed in between 1980 to 2000. The example of second generation fluoroquinolones are timafloxacin, sparfloxacin, grapafloxacin, and gatifloxacin. These all floxacins are active against gram negative, which have a improved gram positive activity. Gatifloxacin is acts on anaerobes, that is, it shows the anti-anaerobes activity. Now stop your video and try to find the answer of this question, that is, what are the structural features of second generation quinolones? As we learned the structural features of first generation, so think about this, what are the structural features of second generation quinolones? Write your thoughts on paper. I think all students are written the answer. Now play your video and try to find the answers. If you look at the structure of ciprofloxacin, then you can easily find out the changes that made in a second generation fluoroquinolones. In ciprofloxacin, 6 carbon is substituted with a fluoro, then 7 is substituted with a piperazine. The piperazine is again substituted with a 2 methyl group which are at 3 and 5 position. The one more fluoro at 8 position. So here is the 2 fluoro that is at 6 and 8 position. 5 position amino group, 3 position carboxylic acid group, 4th position carbonyl group, and N1 is the cyclopropyl. This is structure about ciprofloxacin, very effective drug. Then second drug, the third generation drug is Trovafloxacin. The Trovafloxacin is active against gram negative, gram positive, and it have anti-aerobes activity. Look at the structure of Trovafloxacin. The rest of the structure is the same, somewhat same with the ciprofloxacin with the little changes at 1 and 7 position. At a 7 position, the bicyclo, that is a 6,3-aza bicyclo 310 hexane 3-il substitution at 7 position, and 1 position, that is N1, the substitution is difluorosubstituted benzene ring. This is the change in Trovafloxacin. These are some examples of fluoroquinolones with C8 methoxy, that is the methoxy group which is present at 8 position. The first example is gatifloxacin, a very famous drug where the methoxy group at 8 position. Then moxifloxacin is the drug, is the fluoroquinolones where the methoxy group at 8 position. So these are some examples of fluoroquinolones. These are the references which I used to prepare this presentation. Thank you all. Happy learning.